Alrighty, hey, welcome. Today, this video is all about regular polygons and largely about the angles within the regular polygons and how we can figure a bunch of things out about them. Let's go blue today, see what goes on with that. So let's get amongst it here. So today in class we started, we sorted out our different polygons, and they're all down here. And I'm not going to fill in this sheet. I'm pretty sure you can do the matching if you want to, if you need to, just matching up the names of the side, number of sides versus the names of the various things. And we have names, as you'll see, for certain ones, and get to a certain point we just start talking about how many sides it has. So if you want to fill that in, great. If you don't want to fill that in, that's fine too. As we'll have done this by the time you see this video, I'm pretty sure. Okay, if I can predict into the future, which I think I can, don't need the Java update. Let's go full screen, just for fun. There's that. All right, so triangles. Let's talk a little bit about triangles as we work our way through. I think I want the pointer to work out this exercise right here. So what I'm going to do is I'm going to make some copies of this particular triangle. In fact, I'm going to make 3 copies of it. Okay? And here's what I'm going to do. I am going to, let's see, what am I going to do? I'm going to get my pen back. And I'm going to label this angle A, that angle B, and this angle C. Okay? What I'm then going to do is I'm going to put my pointer back. I'm going to line this triangle right here. As close to next to it as I possibly can. Okay? And I'm going to take this triangle right here, and this one right here, and turn it upside down. This is like, it's pretty close. If all has been done correctly, some manipulation errors here. Okay, there we go. We can do it. I should be able to squeeze that one right in there, like so. Alright, so let's get the pen back and see what we know. Okay, we know that this is angle A, this is angle B, and this is angle C. And when I turn it upside down, this right here becomes angle B, right? Angle A is over here, and angle C is right there. Okay, so notice I get angle A and angle B and angle C right next to each other. Right there. It's acting weirdly today. So right there, and those 3 angles come together to make a straight line, right? See that? Make a straight line, and how many degrees are in a straight line? 180 degrees. That's right. And how many degrees are in a triangle? 180 degrees. Okay, so you've probably known that, you've heard that before. You may have even seen this little demo, but I just wanted to give you at least one way to kind of have a good feeling that 180 degrees is in a triangle, other than me or somebody else just telling you that. So every triangle has 180 degrees. I can do the same thing with this, but in the interest of time, I'm not gonna move on. Okay, so what we're ultimately, our goal is to figure out how many degrees are in any shape that we have. Okay, we could probably quickly do a square, but then we can get into pentagon, hexagon, octagon, and or septagon, I guess is that one is, and what have you. So here's what we're going to do. I'm going to get out of here because I need my little line tool to be able to do this. I'm going to try to divide all these things up into triangles. Okay, so clearly a rectangle I can make into triangles pretty easily, and a rectangle or a square, 4-sided figure has 4 sides. I can get 2 triangles out of it. Okay. If there's 2 triangles, we know a triangle has 180 degrees, so I get 2 times 180, which is 360 degrees. Okay. I could do that same thing here with this one. Now, I know you might be going, well, I could put 4 triangles or 8 triangles or 100 triangles in here. We're going to try to get the least number that we can, and we typically want our lines to start at one of the vertices of the triangle. So if I start, let's just start at this vertice right here. I get 1 triangle. I get another. Okay, so at this point, with just 2 lines, I've got 3 triangles. I've got pretty much the minimum number of triangles. I don't want to start like doing a line over to this side and a line to that side and making extra triangles. I want to get the least number that I can. That's my mission on this task. Okay, so if I have let's see, 5 sides, how many triangles did I get? 3 triangles. So the total of all the angles, and I'm talking about the total of all of these angles right here, is going to be 3 times 180 because there's 3 triangles. Every triangle's got 180 degrees, so that's going to be 540 degrees. Okay. Similarly with this thing, I'm going to go just old school here. I can get 1, 2, 3 lines. Oops, again, that's a line. And that gives me 1, 2, 3, 4 triangles. Okay. So if I have 6 sides, I get 4 triangles. Total angle sum, 4 times 180, which is 720 degrees. Okay, so maybe you're seeing a pattern. Yeah, well, obvious pattern is as the sides go up, the number of triangles go up. But is there a relationship between these numbers here? You see what's going on? Is there a way, if I told you, the number of sides, let's skip 7. If I tell you 8, how many triangles do you think I'm going to get? If you said 6, you are correct. Okay, and hopefully you didn't just go 7, 8, 4, 5, 6. Okay, the pattern seems to be that I can get 2 less triangles than I have sides. So whatever the number of sides are, if I subtract 2, I get the number of triangles. I take that number and I multiply it by 180. Hey, it's past the hour. So 6 times 180, 360 times 3 is 1080, I think. You can check my math on that. You know what time it is? 34 past the hour. 4 calling birds, 3 triangles, 2 lines, and a... Alright, I was distracted. But meanwhile, the sum of the interior angles of a polygon. So the pattern is, if n equals the number of sides, then the angle, total angle, equals the number of sides minus 2 times 180. Okay? Number of sides minus 2 times 180. Because this is how many triangles I get. Okay, I always get 2 less triangles than there are the number of sides. And I multiply that by 180, and that gives me the total angles in any polygon, some of the interior angles of a polygon. Okay? See, was there more? I guess that's about it. Let's just see. Let's get us a polygon, because I do want to talk about at least one more thing. Take a 6-sided one. Okay? So if I've got a 6-sided polygon, the total number, the sum of the angles, okay, so n is equal to 6, because it's a 6-sided, it's a hexagon. So the total angles is going to be formulas n minus 2 times 180. Okay, and it's 6, so I do 6 minus 2 times 180. I do 4 times 180, and I get 720. Okay, so someone might ask you, okay, so the total is 720. What is each angle? Okay, what is each angle? And since this is a regular polygon, and regular, we hopefully know that means all the sides are the same length, all the angles are the same. So if I want to know the total, each angle is going to be the total divided by the number of angles. 720 divided by 6 is 120 degrees. Okay? So if you want like some sort of formula, you take the formula, n minus 2 times 180, divided by the number of sides. Should we write that down? Yeah, let's write it down here. Okay, so each angle n minus 2 is 180 divided by n. Okay, I want to know each angle. And this only works for a regular polygon. If they look the same, then we can get the total. This is the total. And this is the number of sides. And the number of sides is the same as the number of angles. I just don't want to mess up what we're talking about. Okay, I think that's about it on this, regular polygons. I think that gets us the information that we need, how to find the sums of the angles, and that's about all I'll say. All right, so thanks for watching. If we pick something up, if you have questions, please ask. If you're curious, you might want to try to figure out if we know the sum of the interior angles inside, in a regular polygon. How do you find the measure of this angle right there? So a little extra something for you to think about. And now I'm officially done. Oops, went over the 10-minute mark. Thanks.